In this video, we're going to take a look at an example for setting up the probability distribution for a card game. So a probability distribution, our goal is to basically lay out, here is every single possible scenario, and here is the probability of each one of those scenarios. So let's take a look at our game here. So suppose that we have a game that costs $1 to play. That's going to be important for us down the line. You draw one card from a standard 52 card deck. Now I have all of the cards from a 52 card deck right here. We can use that if we're not totally familiar with a deck of cards. This says you win $2 if you draw a heart, with the exception of the ace of hearts, because that's going to have its own special rule. You win $10 if you draw an ace. Here we are including the ace of hearts. $20 if you draw the king of spades, and you win nothing if you draw any other card. We want to create a probability distribution for our profits. So the profit is how much money we get to keep at the end of this. Remembering, hey, this game just cost me $1 to play. I had to pay somebody $1 just to get to play this game. So I'm going to have to take that into consideration. So when I set up a probability distribution, it's going to look like a little table. I'm going to create this little table right here, where here I've got my profits, and then underneath that I want to talk about the probability of getting that particular profit, probability. And you can have your table oriented vertically or horizontally. I'm just using this horizontally because it's a little bit more room that way. So I like to start by thinking about what's the kind of narrowest case. Let's work this from easiest to hardest. Let's think about the easiest possible case to consider. So I'm going to actually jump ahead here and look at this part. This says we win $20 if you draw the king of spades. So above this, just so that I can kind of help myself remember, I'm going to write out, the scenario. So this is the king of spades. Okay, so what do we know? With the profits, we win $20, but we have to remember that the game cost me $1 to play. So I get $20, I take away 1 for the cost, I end up with 19 for my total profit. So my total profit's going to be 19 here. I'm going to erase this work. And then I want to talk about the probability. So I'm just drawing one single card. So out of the 52 cards that are in that deck, I'm going to say, well, how many king of spades are there? So the spades are this row right here. It's that shape. And the king of spades is going to be this card right here. It's the king of spades. There's only one of those. So the probability that I draw that king of spades is going to be 1 out of 52. If you wanted to give a decimal for that, let's see what that would look like. 1 out of 52 is 0.019. So either 1 out of 52 or 0.019. And that's all I need to do for this first outcome. I've talked about the profit and then the probability of that profit. I've given both the decimal and the percentage. The fraction and the decimal. All right, so there's the first case. Let's go ahead and consider another case here. And I'm actually going to kind of work my way backwards here. And just so that I can keep track of them, we've counted the king of spades. So I'm going to get rid of that one right there. That's one card, one possibility that we don't have to consider now. So going back, now we say we win $10 if you draw an ace, including the ace of hearts. So when I talk about the aces are going to be this row right here. So let's talk about the profits first. So we win $10, but again, remembering that we had to pay $1, so this is for the aces right here. We win $10, but we take away 1 for the cost, so this ends up looking like $9 altogether. So our profit is going to be $9. And now we should talk about its probability. So I am still pulling from a standard 52 card deck. So out of 52 altogether, how many aces are there? Well, there are 1, 2, 3, 4 aces right there. So there's going to be 4 aces out of a total of 52. If you wanted to simplify that fraction, that would look like 1 out of 13. These are both divisible by 4, so we can divide them both by 4, get 1 over 13. Or if you wanted the decimal approximation, we would say 0.077. And there's the probability for aces. So we have, here's the profit of drawing an ace, and then here's their probability of that outcome occurring. So we have everything we need. Moving on, what else do we get? We win $2. So we win $2 if we draw a heart, with the exception of the ace of hearts. So we've counted all the aces. I'm going to go ahead and cross those out because we said, okay, we've taken this possibility into consideration, this one, and this one. So I want to think about, for my hearts is my next category. So thinking about the hearts right here. How many hearts do I have? Well, I can count them up if I wanted to, and I could say, well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hearts altogether. So there are 12 hearts out of a total of 52 cards in my deck. So 12 out of 52. If you wanted to reduce that fraction, we certainly could. They're both divisible by 4 once again. That is the same as 3 over 13. Or if I wanted to give the decimal, 0.231, rounded to 3 decimal places. But I actually skipped a step here because I didn't talk about the profits. The profits, I win $2. So I win $2. Hey, cool, I win $2. Oops, I win $2, but I have to take away the cost of the game. So 2 minus 1, I only get to keep $1 at the end of it. So not bad, but not the best possible scenario. So those are my hearts. So I've talked about the first 3 cases. I have one last case to consider. So what haven't we talked about yet? We have not talked about this last case. You win nothing for any other card you draw. That's the last case that we need to consider. So let's talk about the profits first. So I'm going to talk about basically everything else. So let's label this as everything else. You didn't win anything, so we won a total of $0 minus the $1 cost to play. We actually end up with a profit of negative $1. So actually, let's get rid of that because that might be potentially confusing. Let's just say negative $1 is my profit there, which means I lost $1, which that's no good. That's obviously a situation that I want to avoid, but it is a potential outcome of this game. Now, we could, if we wanted to, we could say, okay, well, we counted these hearts, so let's get rid of those right away. And because we have the cards in front of us, we could just count the remaining cards that I haven't crossed out, because those are the cards that would win me nothing. At any of the cards that I have not crossed out at this point, those are going to fall into this scenario where I win absolutely nothing. Or an easier way to do this would be to say, hey, I could also say, you know what, I know about probability distributions that if I take all of my probabilities and add them together, I should end up with exactly 1. So you could kind of group these 3 previous events that we've talked about, these 3 right here, and say, well, this is just the complement of everything else. So I could just take 1 minus the remainder of my probability. So I'm going to need a little bit more room here. This is going to look like 1 minus 1 over 52 minus 4 over 52. I'm going to use the unsimplified version just so that the decimal is a little bit easier, or excuse me, the calculations are a little bit easier to work with. Minus 12 over 52. So I'm just taking 1 minus each of these probabilities, and that should tell me the probability for everything else. So 52 minus 1 minus 4 minus 12. I should end up with 35 over 52 as that probability. If I wanted to give that as a decimal, that would look like 0.673. So there we go. We have all of our probabilities and all of our outcomes listed. If you wanted to double check and add all of these decimals together, you could pause the video right here and just add those together. We should end up with 1. Because I know that every single probability distribution, if I add all the probabilities up, I should end up with exactly 1. So I think it helps to, in these types of problems, list out the different scenarios, and usually I'm going to do the same thing that I did here, where I kind of start with the smallest, simplest, easiest case, and then I work my way backwards, and I try and find a way to keep track of the